Hello everyone and welcome back. So in today's video we are going to continue the part 2 of this multi-threading. So if you haven't watched this video, in this particular video we have covered how the multi-threading works and where exactly we use multi-threading and how exactly you can make use of multi-threading in your programming. And from the interview perspective also we have discussed few things. So now we are continuing with the coding part, and also we will be seeing today the multitasking and the multi-threading. What exactly is the difference? So let's get started. So before I have already written one program about the multi-threading, how exactly we can execute different tasks using three different threads, and what is that advantage exactly. Before we go ahead and discuss this particular program, I will first explain what exactly is thread and how we can create a particular thread. So I have a notes created. I have created a notes here. Let's discuss this first. So there are two ways to create a thread. So basically you can use the thread class to create a thread, and the other way is you can create a runnable object. Basically it's a interface, so you can implement an interface and like you can create a class and you can implement the runnable interface. So using two ways you can create a thread. So let's see the first way here. So here I have created a class myThread, which is extending this particular thread class, and as it says you have to override its run method. So for example, suppose I have created a class which is extending a thread, and we already know that thread class has one method called run. Now we are overridden this particular method. So whatever operation we want to perform inside this, we can perform here. Now from the main method, I am creating the object of this particular class, and we have a method called start. So using this particular class reference, I am calling this method start, and once we'll call the start method, it will internally execute this particular run method. Now the second way is using the runnable interface. So by using the runnable interface, there is not much difference. Only difference is it also has the run method which we can override. But here what we have to do is we need to create a class first. Sorry, we need to create an object of this particular class, and then in a thread reference we need to pass this particular class reference. We'll be seeing this in detail, don't worry. So let's go ahead, and here also I have mentioned the run method contains the code that will be executed when the thread is started. To start a thread, you can call it start method, which invokes the run method. Okay, so let's get to the code first and let's understand how exactly this multi-threading works in a programming perspective. So you can see we are using the second method using runnable interface. So if you see, I have created three separate classes. I am highlighting those. This is the first class, task1. This is the second class, task2, and this is the third class, task3. Okay, now in first class I have the method fetch user details. From last video, if you remember, we were discussing about the user details, how exactly we can do different operations using different threads. So here we have fetch user details, here we have get user consent, and then we have get transaction details. Okay, that is the private method, all inside different classes. And now I am calling this particular method from this run method here, and I am calling the user consent from here, and then I am calling the fetch user details from here inside this run method. So all these classes are separate, three different classes. Now if you remember this particular example, how we are doing it is we have already one class which is implementing a runnable interface, and here we have created an object, and then in thread class we have passed this. So this is the second way. So we are using the second way. We are creating an object of the thread class, and now instead of going ahead with another step, we directly are creating object and passing it here, rather than creating object separately here and then passing its reference here. We have directly passed this particular thing inside this. So that is what we are doing. So we have one thread 1, thread 2, and thread 3. Using this class task 1, for task 1 we have created thread 1, for task 2, task 3 we have thread 2 and thread 3. Now we can remove this code, it's not useful for us. Now you can see we are starting thread 1 and thread 2 and thread 3. So thread 1 will call this particular run method because it is the reference of this task 1. Then thread 2 will call this run method and thread 3 will call this run method. Okay, so now how exactly this will make difference in real time applications? So suppose if we don't have 3 threads, so how exactly this thing will work? If we need to execute 3 different methods, fetch user details, get user consent, and then get transaction details. Suppose we have 3 methods, we are calling 3 methods from here. So first fetch user details will be called. Once it will process it, everything will be completed, then we can fetch the user consent, then we can fetch the transaction detail. But here what we are doing, we are not waiting for anything. The thread 1 will run independently, as we have discussed in previous video. Threads run independently. So thread 1 will start, thread 2 will also start, and thread 3 will also start. It will start doing its work. It will get the user details. If we have a DB call or whatever it is from database we need to fetch, so thread 1 will do that work. Thread 2 will simultaneously get the user consent, and thread 3 will simultaneously get the transaction details. So all these things will happen at the same time, and it will return the result in a faster way. So this is how the thread will work, and that is why it is useful to use in a bigger application, so that your runtime can be reduced. So if we run this particular application, if you see, we are getting result user details fetched, transaction detail fetched, and user consent fetched. If you see, the first we are calling thread 1, then thread 2 and thread 3, but you can see user details fetched we are getting first, then we are getting transaction detail. That means that thread 3 is getting executed before thread 2. So as it is running parallelly, it is running independently, it does not care about thread 2, what thread 2 is doing or what thread 3 is doing. They will try to get result from their own perspective. It will run and it will try to get the result. So suppose if we'll run this time, it may differ. See, if it is same, but it can differ. Okay, if we'll run this, sometimes thread C, now here user details we are getting first, then user consent, and then transaction details. So all these threads are running separately. Now in interviews also, we may interviewer may ask, like, what is the difference between multitasking and multi-threading? So let's discuss that also. Multitasking, actually I have written here multiprocessing, multitasking or multiprocessing you can say. So for example, imagine a particular company which has a large number of tasks to complete, and there are different processes. So what we can do is, multiprocessing is nothing like, it would divide the task into separate departments. So suppose if we have 3 departments in an organization, so multiprocessing is nothing but a particular department will have one process, one particular department will have separate process. So these processes, if we have these kind of things, we can divide the processes into different categories. Okay, so multi-threading, in other hand, suppose we have one particular process, and now under that we have different tasks. So suppose we have one department which handles with transactions. So now inside the transaction we can divide subtasks, and then we can run the threads to get each subtask done. Okay, and now the question comes, when should we exactly go for multiprocessing? So suppose you can use multiprocessing when you have a large complex task and that can be divided into smaller subtasks. So then you can go for the multiprocessing. Okay, and how exactly we can decide that if the multiprocessing will work for my program or not? So that depends on number of factors. The number of available processors or cores is one factor. So now we have seen that my CPU or my processor is a multi-core processor. Somewhere we have heard earlier there was some single core processor. So that's where this particular thing comes into the picture. So if you have a multi-core system, you can use multiprocessing to take advantage. If your system has single core, then multiprocessing will not be much effective. But it's not like multiprocessing will not work. It will work, but there we have a concept called IO concurrency, which we can use. IO concurrency we are not going to discuss, but you can go ahead and search. And if you find any difficulty, we can create a video on that also. So hope you are able to understand basically the multi-threading concepts, how exactly we can run this in our application and how exactly we can get the faster result, and why now companies prefer to use multi-threading for their faster performances, and now writing APIs, how and their performances can be boosted using this multi-threading. So that is the main purpose basically. So hope I'm able to clear your doubts regarding this, and if there is anything you want me to cover or anything related to this, you can let me know in the comment section. Till then, have a good day. Thank you.